Hello friends, we have learnt methods for solving simultaneous linear equations in two variables by making the coefficients of a variable equal, by substitution, that is expressing one variable in terms of the other to eliminate a variable, and by the graphical method. A method for solving simultaneous equations that is simpler and uses minimal space is the determinant method, which was developed by the mathematician Kramer. Today, we will study this determinant method. Gabriel Kramer, a Swiss mathematician, discovered this method, which is why it is called Kramer's rule. You might be wondering, what is a determinant? Let's learn what a determinant is. What is a determinant? Look at this arrangement. The digits 3 and 2 are in the first column and the digits 4 and 5 are in the second column. This is a determinant. A determinant is a number. Let's see how to find the value of this determinant. Value of above determinant is equal to 3 into 5 minus 4 into 2 equal to 15 minus 8 is equal to 7. Here we have multiplied the numbers in the determinant diagonally. In the general form, a determinant can be written as follows. Now in this determinant, the elements A and B and C and D are written in horizontal rows, while A and C and B and D are written in the two vertical columns. This determinant has two elements in each row and two elements in each column. A determinant of this type is said to be of order 2. The value of the determinant A and B, C and D is AD minus BC. English capital letters A, B, C, D, etc. are used to name a determinant. Let's study a few examples of how to find the value of a determinant of order 2. Let's see the first example. Suppose determinant A is equal to 2 and 3, 5 and 4. Therefore, A is equal to 2 into 4 minus 3 into 5 is equal to 8 minus 15 is equal to minus 7. Second example. Determinant B is equal to 2 and minus 3, 5 and minus 4. Therefore, B is equal to 2 into minus 4 minus minus 3 into 5 is equal to minus 8 plus 15 is equal to 7. Third example. Determinant C is equal to 1 upon 2 and 2 upon 3, 3 upon 5 and 4 upon 5. Therefore, C is equal to 1 upon 2 into 4 upon 5 minus 2 upon 3 into 3 upon 5 is equal to 2 upon 5 minus 2 upon 5 is equal to 0. You must have understood by now how to calculate the value of a determinant of order 2. Kramer's rule for simultaneous equations. Now, let's learn how to solve simultaneous linear equations in two variables using determinants, that is, by Kramer's rule. Suppose the given two simultaneous equations are a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. Now from these equations, we write the determinant D as D equal to a1 and b1, a2 and b2. Note that the constant terms c1 and c2 are not included in D. This is the determinant of the coefficients of x and y. Now let's write the determinant dx as dx equal to c1 and b1, c2 and b2. What difference do you see between d and dx? You got it right. The column of x coefficients of determinant d, a1 and a2 are replaced by the column of constant terms c1 and c2. Now Let's write the determinant dy as dy is equal to a1 and c1, a2 and c2. Now, what difference do you see between d and dy? You got it. The column of y coefficients of determinant d, that is b1 and b2, is replaced by column of constant terms c1 and c2. To find the solution of the given equations, you need to calculate the values of the determinants d, dx and dy. Then use the following formulae to find the values of x and y. X is equal to dx upon d and y is equal to dy upon d. Let's solve an example using this method so you can understand it better. Let's find the solution of the equations 5x minus 2y minus 19 is equal to 0 and 7x plus 3y minus 15 is equal to 0 using Cramer's rule. Solution: the given equations are 5x minus 2y minus 19 is equal to 0 and 7x plus 3y minus 15 is equal to 0 using Cramer's rule. First, write the given equations in the standard form ax plus by equal to c. Therefore, 5x minus 2y is equal to 19, equation 1, and 7x plus 3y is equal to 15, equation 2. Comparing equations 1 and 2 with a1x plus b1y equal to c1 and a2x plus b2y equal to c2, we get a1 equal to 5, b1 equal to minus 2, c1 equal to 19 and a2 equal to 7, b2 equal to 3 and c2 equal to 15. Now, determinant d is equal to a1 and b1, a2 and b2 equal to 5 and minus 2, 7 and 3 is equal to 5 into 3 minus 2 into 7 equal to 15 minus 14 equal to 15 plus 14 is equal to 29. Therefore, d is equal to 29. Determinant dx is equal to c1 and b1, c2 and b2 equal to 19 and minus 2, 15 and 3 is equal to 19 into 3 minus 2 into 15 is equal to 57 plus 30 is equal to 87. Therefore, dx is equal to 87. Determinant dy is equal to a1 and c1, a2 and c2 is equal to 5 and 19, 7 and 15 is equal to 5 into 15 minus 19 into 7 is equal to 75 minus 133 is equal to minus 58. Therefore, dy is equal to minus 58. Now, let's use the formulae x is equal to dx upon d and y is equal to dy upon d to find the values of x and y. Therefore, x is equal to 87 upon 29 is equal to 3 and y is equal to minus 58 upon 29 is equal to minus 2. Therefore, the solution of the given equations is x, y equal to 3 minus 2. Do you now understand how to find the solution of simultaneous linear equations using Cramer's rule? For practice, complete the following activity. With practice, you will understand this concept better and you will be more confident while using Cramer's rule to solve simultaneous equations in two variables. What did we learn? A determinant where each row has two elements and each column has two elements is called a determinant of order 2. Example, let determinant d is equal to a and b, c and d. The value of the determinant d equal to a and b, c and d is ad minus bc. To solve simultaneous equations a1x plus b1y equal to c1 and a2x plus b2y equal to c2 using determinants, that is Cramer's rule, the following formulae are used. X is equal to dx upon d and y is equal to dy upon d, where d is equal to a1 and b1, a2 and b2. Dx is equal to c1 and b1, c2 and b2. Dy is equal to a1 and c1, a2 and c2. Exercise. Find the values of the following determinants. Solve the following simultaneous equations using Cramer's rule.